What will our L be? 0, 1, 2, and 3. And that will be 4s, 4p, 4d, 4f. Abi, if you add all of the electrons together, it will give you 32. She gets. So that's it. So the next one is called magnetic. Quickly. Magnetic quantum numbers. So magnetic quantum number gives what we call spatial orientation. Spatial orientation, also known as orbital degeneracy. Orbital degeneracy. Spatial orientation or orbital degeneracy. It's talking about those P divided to 3, D divided to 5, F divided to 7. That's what this one is trying to tell us. And S is not divided. And the way the shapes are and all of those things. But don't forget that S has its shape, Abi. Spherical, dumbbell, double dumbbell, complex, Abi. That's so let's look at this. This one is denoted as M sub n, magnetic quantum number. It gives the value from minus L through 0 to plus L. So whatever the value of L is what ML will be. There are several questions you can see on this. And there are ways in which they can mix all the questions together. So if you have some questions, you can give me so that we'll do them together so that you understand it better. So quickly, let me explain this part. You know that we said when n is equal to 1, what will L be? 0. Abi, ML will now be, since L is 0, there is nothing like minus 0, 0 plus 0. No. So if L is 0, then ML will also be 0. That means that it will not be divided. It's just 1. So that means this is 1s. Then it has just one orbital. I hope you are following that. Let's do the second one. When n is 2, what do we have? L is going to be what? 0 and 1. Abi? That means that's 2s and 2p. This means if this one, let me do that. That's 2s and 2p. So if L is 0, when L is 0, ML is going to also be what? 0. That means for S, we only have one shell. When L is 1, ML is going to be what? Minus 1, 0, plus 1. Do you get? That means it's going to be divided into 3. And when L is 1, which orbital is that? P. And that's why we have this one in 3 places. Are you getting the light? So that means this one will be divided into just 1. Then this one will be divided into 3. So the one giving us 3, we call it threefold degeneracy. Threefold. 1, 2, 3. Threefold degeneracy. They are orbitals of the same energy. We call them degenerate orbitals. So p orbital is threefold degeneracy. D orbital is fivefold degeneracy, and the last one is sevenfold degeneracy. Are you done? Oh yeah, can we do for when n is 3? What will our L be? 0, 1, and 2, Abi. Are you there? So now this will be 3s, 3p, 3d. Now let's look for ML. ML depends on values of L because it says it takes minus L0 plus L. So when L is equal to 0, ML is also going to be what? 0, one shell. When L is 1, ML is going to be minus 1, 0 plus 1. Abi, that means 3. That means this is P, this is S. S is not divided, P is divided into 3. So when L is now 2, which is D orbital B, so ML is going to be what? Minus 2, minus 1, 0, plus 1, plus 2. And that means D will be divided into how many? 5. 7. Wow. Do we get that? Is that okay now? Oh yeah, do for the last one. Let's not even do for the last one. Oh yeah, number 4. We call this one spin quantum number. It's spinning on its own. So for spin quantum numbers, we have This one is just talking about if you are putting electrons in this orbital now, one will face up and one will face down. So the spinning of those electrons on their axis is what we call spin quantum number. So one electron always spin up, one will always spin down. So spin quantum number is denoted as m sub L. M sub S is talking about the spinning of the electron on their axis. Spinning of electrons on their axis. And at the end of the day, m sub S has the value of plus or minus 1 over 2. And that's it. When you have plus 1 over 2, it means the electron is spinning up. When you have minus 1 over 2, it means the electron is spinning down. So let me now give you something from the old story. Yoruba, we call it atotonu. So from the old atotonu since morning, if n, let's say I give you this, 4s2, 4s2. Oh yeah, let's analyze 4s2. There are 2 electrons here. For 4s2, that means there's 1 electron and another electron, 4s2. What is their value of n? What's their value of n? What's their value of ml? And what's their value of n sub s? That's why that guy called polar exclusion principle states that no 2 electrons can have the same set of value for the 4 quantum numbers. These 2 electrons cannot have the same set of value for the 4 quantum numbers. So can we settle this now? Oh yeah, what will n be for this orbital? Very good. What will L be? So don't say 0, 1, 2, 3 because I'm only showing you what? S. Do you get that? So you say L is 0. And if L is 0, what will MS be? So what will MS be? Plus or minus 1 over 2. But we can do them separately. You can say the one spinning up, Abi, so you give it plus 1 over 2. Then you do for the second one too. Then N for that one too will be 4, meaning that it's also occupying the same energy level. Then L for it will be 0. ML will be what? 0. Then M sub S will be minus 1 over 2. So no 2 electrons can have the same value for the 4 quantum numbers. At least they will be different in one position. That's what polar exclusion principle states. But that's not your problem for today. That's a problem for a beginner of chemistry, a starter of chemistry, SS1 student. You know that one now when you were in SS1. Are you done? Please, do we understand quantum numbers now? Let's solve questions on that because there are different ways questions are always that. So, what's it, Pade? Page 7, number 23. Then we're on. Page 7, number 20. Then we're on. Show me that one. So there's question on page 7, number 20 and 24. Let's quickly answer that, then you answer the rest. Oh, ṣé wọ́n mú ní kó bẹ́ẹ̀ sọ? Má bínú. Má bínú. Owó tó send to me last time, mo ṣe ń ná, má bínú. So mo ń expect mi lálẹ́ 50,000 naira. God bless you. Anahanat, anatanat, lesalianatanat. Under G, ní ti wà fẹ́ mọ orúkọ ẹ mọ́. Under G. Teju? Yes. Shalom. Shalom. What's your own name? Olujobi. Gabriel. Clemens. Clemens. Over just cement. Clemens Olujobi. Oluwajobi. Clemens Oluwajobi. The name looks nice. Clement Oluwajobi. Your wife will be so proud in the future. Ah, look at my husband's name. Oluwajobi, darling. Number 20. Are you there? They said, consider an orbital. Oh, really? What ṣe mí? Wọ́n ti lu ayé wa. Lè win. Win. But kò lè jẹ́wọ́ ló score. Midfield ló máa wà. Midfield. Olójòrò òṣì. Àwọn yẹn náà inú wa dẹ̀ máa dùn bẹ́ẹ̀. Ta lè play náà? Ìgbẹ́ ìgbẹ́ ta ni láàyè ní tí wàá tún àṣírí ẹ̀ sí. Ta lè play? Okay, 100 level play, 300 level pharmacy. Ẹ wá náà wọ́n. Ìwé ti ṣe wọ́n léṣe. Wọ́n ráyè football mọ́. Pharmacy ti dè wọ́n lọ́rùn mọ́. So, consider an orbital description as follows. Now, this is the description. N is equal to 3. L is equal to 1. Consider the orbital description as follows. N is equal to 3, L is equal to 1. Which of the following statements are correct? Which of the following statements are correct? Roman figure 1. It is a 3D orbital. Is that correct? Which orbital is it? 3p. You can see that it's simple. 1. Roman figure 2. It is 3p orbital. Roman figure 3. It is a degenerate orbital. Is it a degenerate orbital? Yes, now p. You know, p will be divided into 3. All those orbitals with the same energy are called degenerate orbitals. Like all of them that are divided. She gets. They are called degenerate orbitals. Do you understand that? Roman figure 4. Like a UI question. It has m sub L values of -1, 0, and 1. True or false? True. Abi? Then Roman figure 5. It has ml values, m sub L values of -2, -1, 0, 1, and 2. That's false. So the answers are 2, 3, and 4. Is that taken? So number 24, before we move on to the next thing. Which of the following sets of quantum numbers is or are permissible of an electron in an atom? Which of the following set of quantum numbers is or are permissible? Are you fine? Are you following what we are doing? Are you sure? Dabi Orishabun. Do you know who Orishabun is? Gen Z. Some students who do not know video cassettes. Ta ló mọ video cassettes nínú yín? Bright ṣe máa mọ̀ náà. O gbọ́dọ̀ máa mọ̀. Lórí àti rí ẹ̀lú ayé ìbàjẹ́ kékeré. You know those video, not DVD, not disco, that you rewind it. If you finish watching the film, to watch it again, you have to rewind. It's like rope. So you have to wind everything back. You now insert it. It will now start from the beginning. The cassette is like this. You dip it inside, you now be winding one. It's spoon we used to use. The dip spoon. But it's in by you just scroll. Ṣé yìí rí TV tó jẹ́ pé wọ́n máa ti gí báyìí? Tó bá fọwọ́ kan lé yín wọ́n á fẹ́ lu ayé ẹ̀ bàjẹ́. It's a TV that they will close the door like this and they will open the door. The only person that has the key to that TV is your daddy. Any other person can. That's if your daddy has it. Because your daddy even can go to another neighbor's house to go and watch. Which of the following sets of quantum numbers is permissible of an electron? Roman figure 1. N is equal to 1, L is equal to 1, ML is equal to 0, MS is equal to plus 1 over 2. Roman figure 2, N is equal to 3, L is equal to 1, ML is equal to minus 1, MS is equal to minus 1 over 2. Roman figure 3, N is equal to 2, L is equal to 1, ML is equal to 0, MS is equal to plus or minus 1 over 2. Roman figure 4, N is equal to 2, L is equal to 0, ML is equal to 0, MS is equal to 1. So they are saying that which of the following set of quantum numbers is permissible. So you can go and solve the rest. So let's check which one is correct. Èwo ló wà permissible, which one is possible? Which one do you think the combination is sensible? For Roman figure 1, if N is 1, can L be 1? It's not possible. So Roman figure 1 is not permissible. Roman figure 2, if N is 3, can L be 1? If L is 1, can ML be minus 1? Can MS be minus 1 over 2? It's possible. It's possible. You don't know which one you are talking about, so it can either be either way. Roman figure 3, if N is 2, L can be 1, Abi. Can ML be 0? Yes. MS can be plus or minus, so it's permissible. If N is 2, L is 0, ML is 0, is that permissible? Yes, but MS cannot be 1, Abi. So that's it. So this is not permissible. So you have 2 and 3. So that's all. That's all on quantum number. Do you get what we are saying now? So can we move on to the next thing? What's your next problem? So the next one on my agenda from what you said or you sent to me on WhatsApp is aldehyde and ketones, Clemenson and Wolff-Kishner reduction. Clemenson and Wolff-Kishner reduction, the word reduction. You take an aldehyde, it's very simple. It's just the reagents that are different. Clemenson's, what's Clemenson's reagent? When you hear Clemenson reagents, what do we mean? Let me change the marker because of those online, in case they are not seeing the body. But like even if we use like 1 week, we can finish the whole physics and chemistry and biology. If you use like 1 week. Or is it that you go and sign me out of medical school and say, Bobo alone, Shema? If I give you the whole of 1 week, just put knife on my neck like this and say, this boy said he's not doing medicine again. He's tired of medicine. In one class like this, they can teach you almost like a whole textbook. So, Clemenson reduction and Wolff-Kishner reduction. It's just story. The most important thing is the word reduction. It is used only, this reaction is only used for carbonyl compounds. When you convert carbonyl compounds to alkane, then you are undergoing reduction. You convert acanone or acana to alkane, then you have Clemenson or Wolff-Kishner. If it is Clemenson reduction, what you have is that, let's take any acanone, for example, CCOC. This is what? Propanone, Abi. Now, in the presence of zinc I think zinc and mercury, zinc amalgam. Zinc amalgam. Because they can ask you Clemenson's reagent. So, what other catalyst do you use? Zinc amalgam in bàbá fẹ́ mọ lójú àríran ọ̀yẹ̀là ìwájú ọ̀la ìkó mọ́. Holy Spirit, show it to me if I cannot see anything. But mo ti pe fátẹ́lẹ̀ mọ́ Holy Spirit, Holy Spirit Adam. Clemenson reduction. Mo fẹ́ wo bí tí hydrogen ti máa wá. It's not water. Ká tó ṣe tán mo lè rántí. So the thing is that you are just adding hydrogen to this guy. Zinc amalgam. It's not in this. So you remove the oxygen, reduction. When you remove the oxygen, then you add hydrogen. Then that's your product. Sorry, Jerry. That's your product now. And that is propane. I only left it there so that, and now, like remove the oxygen, add hydrogen here, and that's your product. Yeah, I can write it the same like this. Hydrogen here, hydrogen. So that's from propanone to propane. So nobody has seen Clemenson's reagents. Zinc amalgam in HCl. In HCl. Ó fẹ́ jọ Lucas reagent. Lucas reagent is also zinc in HCl. That's Lucas reagent. So Clemenson in reagent is zinc amalgam in HCl. Check Wolff-Kishner. That is hydrazine. I think it's hydrazine. Wolff-Kishner's reagent. It's the same reaction for both of them. It's just the reagent that is different. I think it's hydrazine. H2N, NH2. And which one? I think H2N, NH2. Fatima, what is where? Oh, yeah, so? She's using her mouth to kiss her mouth. Her back to shift your book. Ìwọ náà jókòó dáadáa, ó ṣe wá jókòó bí ìyàrúkà rẹ̀. Ṣẹ́yìn rẹ̀ ni, stand up and stretch your back if you are tired. Stand up, jog, jump. So yeah, let's say it's ethanol now. We can have 1, 2. This is ethanol. So what do we do? Add H, add B. What will it give us? Ethane. So converting carbonyl compounds to alkane, that's what is happening. Sometimes they just give it names. But this one now is H2N, NH2. That's hydrazine. Any other thing? Yes, Wolff-Kishner. Okay, in a base. Yes, because it will first form hydrazone. Then hydrazone will now be converted to alkane. So in the presence of hydrazine, it will form hydrazone. Then ethanol hydrazone will now be converted to ethane. So it's a 3-step reaction, but this is the overall reaction. So conversion of carbonyl compound to alkane. So this is Clemenson's reduction. You can also, reagent is just the difference. Why this is Wolff-Kishner's, Miss Clemenson's reagent, in case they ask you. So which one is next? I have taught you dry distillation. So the next person said organic chemistry. We move on because that's what we have been doing since morning. Double bond equivalence. DB, do we all know how to do double bond equivalence? Hey, pẹ̀lẹ́ Fatia, jẹ́ kí n ṣe torí tiẹ̀. Kò sí ní iṣẹ́ UI, bí ọ̀ lè bá béèrè. So CNHX, CNHX, plus, plus, minus, minus. So for double bond, what I mean by CNHX is this, like 2C plus 2 plus N minus H minus X all over 2. That's the formula. That's the formula for double bond equivalence. CNHX plus plus minus minus. Sometimes the formula is to look like it does not want to stay. So this is the formula for double bond equivalence, but let's talk about it properly. So we still young, dumb and broke, but we still got love to give us young now. Who is calling? It's not showing. YouTube will flag us using someone's song. So, Ismaila. So double bond equivalence is just telling us about level of unsaturation. You want to know the level of unsaturation of a compound. We call it dBe. The level of unsaturation of a compound is called dBe. That means you want to know the number of double bonds that is present in a compound. They didn't give you the structure. They didn't give you, but you can guess. You want to know the number of triple bonds. You want to know if there is a ring structure present. That's what you want to know. So they just give you a compound and they say determine the double bond equivalence. Look at this now, C6, H6. I want to know how many double bonds or rings or how many level of unsaturation do I have. That is what I want to check. I want to check if there is double bond, if there is triple bond, if there is a ring. Those are the things you check with double bond equivalence. For this now, this is the formula. C represents the number of carbon. N represents number of nitrogen. H represents number of hydrogen. X represents number of halogens you can have. Samuel, are you missing where you do? You want to reject UI? Choosing me, so you. Honest thing is, I swear, if you write it, you will get it. If you write it, check out better. Yes. Check out better. So now, in this place now, we did not have nitrogen, but we have hydrogen and we have carbon. So we can say that dBe is going to be, how many carbon do we have? 6. So that will be 2 times 6. Shall get plus 2 plus, we don't have N, so that will be 0. We want to know the number of structures that are possibly present here. Do we have hydrogen? Minus 6 minus, we don't have halogen, all over 2. 2 times 6 plus 2, 14 minus 6. That will give us 4. Abi? And if you look at this structure, that's benzene, Abi. So that means it's because I know, because you really cannot tell. But here now we got 4, meaning that we have 1 double bond, 2 double bond, 3 double bond, and a ring. That's what makes 4. Do you get that? That's it. So double bond equivalent just tells you the level of unsaturation. You didn't get how many double bonds we have here? 3. 1, 2, 3. Then we also have a ring, Abby. So one ring, 3 double bond. Everything makes 4. That's what this formula always tells us. It's because I already know this benzene. That's why I could draw it. Sometimes you might be confused and not know what to do. Let me give you this now. If I have what would be the double bond equivalence for this? C3H4. It might be ring, it might be triple bond, it might be double bond. But most times, triple bond always counts as 2. So I think that settles double bond equivalence. Just know the formula. They just, where you can ask you if they do not change their. So the last topic. They even said that it might not be possible to cover all these topics in one day. That we can split it into three topics. In one day. That we can even finish the whole organic chemistry in one day. The whole organic chemistry. If you want to do it from beginning, we can finish everything one day. Even the most important thing is to get concepts right. That's all. The rest are just spamming. Just spam them. The moment you know how to name, you know isomerism is never a problem. You shall know how to name. Then the rest is simple. And yes, there are some. But it's not always correct like that. Have you done it? What's the answer? 2. That's why triple bond always counts as 2. 1, 2, 3, 4. 1, 2, 3. 1, 2. C3, H4. So triple bond always counts as 2. That means they are like 2 double bonds merged together. But I'm only giving you this structure because I already know what it is. So, but your own is that if they give you this thing and say, but if they give you a structure like this, let's say I give you a structure like this because you never can tell. If I give you a structure like this, and I ask you that what is the double bond equivalence? Although you can calculate it, you will just have to count number of carbon and count number of hydrogen and do your math. But you don't need to go through that stress. Double bond 1, triple bond 2. So the answer should be 3. So you won't have to go through the stress of calculating. So you calculate it, what will you get? That's C5, H5. Is that 6? 7. Okay. Hydrogen is what? 6. What do we have? That's 2. Carbon is what? Abby? Is this complete? +2 +0 -6 -0 all over 2. That's 12 -6 Abby all over 2. 12 -6 is 6. So you can see that's correct. So you can just look at it and tell. Is that taken? Hallelujah. What will be the answer for this? Eh? 7. The answer should be 7. Abi? There are 2 rings and there are 5 double bonds. Do you understand that? If you want to check it out, you can calculate it. Just know the number of carbon and know the number of hydrogen. But can you know the number of hydrogen here? You should be able to now. Abi? 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. Carbon. Those are the carbon. 2 times 10, 20 plus 2, 22 minus 1, 2, 3, 4, 5, 6, 7, 8. 22 minus 8, 14. 14 divided by 2, 7. So that's correct. Is that taken? So that's by the way. So just know the formula. That's all you need for where you post-UTM. Then the last one, you say chemical equilibrium. Then dry distillation, it's a common question too. But most of these questions, you just know them because as at last year, all these questions were not asked. Some of them were asked too, they were still asked, but they didn't really ask all those complex ones. This dry distillation was still asked. So let me teach you dry distillation of calcium salt. Is one of the reactions of one of the ways we prepare carbonyl compounds. So preparation of carbonyl compounds. So that's the last part I'll teach you for the day. So when there is chance, we do some other ones. Let me see how far I can go with my study this week. You can still see next weekend. So, what's it called? Your exam is still September 1st, 1 to 5. Today is August 1st now, so which means we can still see next weekend. So just go and practice all these things. And if there is an aspect to have problem in chemistry, still send it to me. You can send it to my WhatsApp. Is that taken? So I'll be piling it up. So anytime I come on weekend too, we do it. And physics, yes. Aspect to have problems in physics, chemistry, biology, pile them up. Just be saying, be reading. No, I'm not saying you should not be reading. No, you just see like this. Problem ni sodium. Problem ni sodium. Be reading like problems that are beyond your control. There are some of it that your classmates, all of you can discuss together. But when you see a problem, it's beyond your control, just send it to me. So by the time I'm coming next Saturday, by God's grace, then we'll do it. Physics, chemistry, biology, then we'll do it. So this is a common question in OAU. Dry distillation of calcium salts of carboxylic acid or carboxylic acids. Dry distillation of calcium salts of carboxylic acid to produce carbonyl compounds. At 400 degrees C. You will see this question a lot in your one-time success too. So what they do here is they heat the compound, a calcium salt. Let's say I have, for example, calcium ethanoate. Calcium ethanoate. Because calcium has, if I have ethanoate, this is ethanoate, CH3COO minus. Calcium is what? 2 plus, Abi. So if I change their ions, I'm going to have CH3COO2, Abi, and Ca. Do you get that? Like sodium ethanoate. Sodium ethanoate will be 3CH3COO, Abi. But this one will be CH3COO2, Ca. What they now ask you here is that what are the likely products? With this now, you should get just one product. But they can mix them. So they heat this compound at 400 degrees Celsius. And they say that I should tell them the products we have. Sometimes when I look at it, I just guess. But I like doing it this way. Please help me. So that you don't get confused. Now, this is what you will do. You will write it this way. CH3, C double bond O, O, Ca, O, C, O, CH3. That's what I like to do. This is the compound. This calcium ethanoate. You can see that this CH3COO, that's one. CH3COO, that's two. Then combining with calcium, that's the compound. So dry distillation will help you to remove CaCO3. So you will now remove CaCO3. You can remove CaCO3, anyone. So when you remove CaCO3, then you will join what is left. So meaning that after removing CaCO3, what will I have left? CH3, C double bond O, and CH3. So I'm going to have CH3, C double bond O, CH3, plus CaCO3. So what did I produce? Propanone. Did you get that? Like dry distillation of calcium. This one now is calcium ethanoate. Calcium ethanoate. So dry distillation of calcium ethanoate will give me propanone as my answer. Propanone. So everybody, what will you get for calcium methanoate? Calcium methanoate. What will be your product for the dry distillation? From what I've explained here, it should be very simple. Dry distillation of calcium ethanoate. Actually, when you have ethanoates, there's a shortcut I used to use there. When you have ethanoates, just remove one carbon, then you have 3 carbon left. When you have ethanoates, remove one carbon, you will have 1 carbon left. I don't know if you understand what I'm saying. Look at that first one, calcium ethanoates. There are 4 carbons now because it is calcium ethanoate. 2 ethanoates, Abi, making 4 carbon. Remove 1 carbon, what do you have left? 3 carbons. Then you will have propanone. But be careful, it can be propanol, it can be propanone, depending on the reaction. So here now, just remove CaCO3, then you have propanone. But it's better to always draw it out. That's the best way you will get your right answer until you get used to it. When you are used to it, ordinarily looking at it, you will tell your answer. Are you done? What's our product for calcium methanoates? I'm always ready for the war again. Go down that road again. It's all the same. I'm always ready to take a life again. I ride again. It's all the same. Wait, is it solar that is working or gen? Tẹ̀ ń lo náà rárá bíbá. Solar lẹ́kọ̀ọ́ máa ń lò 247. People are enjoying. Ẹjọ́ ẹ ṣáàjẹ́ kó wúlò fún àwọn next jam set. I want to do projector here. So my own class I always project so that wọ́n á tètè máa parí. Anytime I come, I will cover a lot. Then I will send them the slide. So the next jam set they will use phones. So ẹni tó bá ti wá wù kó tẹ phone, ayé ń bàjẹ́ lọ náà ni. We'll give them orientation when they resume. But life has changed. If you decide not to use phone now, when you get to university and phone becomes your distraction and you start failing, people that will read, people that will pass. So we just need to give them proper orientation. So ọmọ tó bá máa gbọ́n á gbọ́n, ọmọ tí ó bá ní gbọ́n kó continue. Result á bá wájú. We'll try our best. So we'll be projecting my own class so that they can be seeing pictures of everything I'm explaining. Next slide. You should not be staying at the level of. I'll just say next slide. What's it parí here? So only things I need to explain deeper, I'll use marker. So, and I'll teach all of you how to use your tools to learn. Then by God's grace, we should have our app ready too. TikTok. They used to be on TikTok. All of them now, and you will need it when you get to university. You will need most of the AI tools that used to, the way I used to read. Gbogbo ẹ̀ náà, gbogbo yín la lo orientation fún. Around Samuel báyìí, fídíò mi wọ́n gbọ́dọ̀ wò. Wọ́n máa ti parí 100 level báyìí, kọ́ sáré lọ máa wo anatomy. So I'm just trying to think about how all of these things can be easier. Medical school is not easy. It's not easy at all. But most of my work every day, I'm always thinking about all these sets coming, especially all these PRIMAX sets now. I have a group now that already have all the medical students from other universities. They are on the group. So I'll be giving them OT, orientation. This is how your life will be easy in medical school. That's why I'm there. I want to go and make the place easy. That's my purpose there. So anybody coming after me, the journey should be very easy. Somebody is going on. So is that okay? What's your product? Methanol. So just write HCOOCAOCOH. So remove this. What do you have left? CHO. Bí mo ṣe dúró ẹsẹ̀ lómi lè ní methanol bẹ́ẹ̀. So that's methanol. Is that clear? Oh yeah. What if it is what if it's a mixture of calcium methanoate and calcium methanoate? We mix, this is how they ask this one. They will mix the two of them. They will now tell you that what are the likely products. This is what you do. They can mix, this one I said, what's the product for this? This one I said, what's the product of this? In another question, they will take this one and this one, mix them together. And now say that what's the product you are likely to get. So you will get a product for this. You will get a product for this. You will now get a product of joining this and this. Meaning you will get 3 products. Let's look at it. So I said the question is, what are the products you are likely to form from the dry distillation of calcium salt of ethanoate that is mixed with calcium methanoate. So let's check it out. So I check it out. You already know the products you are going to get. So I have a mixture of calcium ethanoate and calcium methanoate. I mix them together and I say, what are the likely products? You will get a product for this guy first. You will get a product for this guy first. You will now get a product for the two of them. This is how you will do it. Let's get a product for the first one. Common thing we used to do. Write CH3, C double bond O, O, Ca, O, C, double bond O, CH3. For this now, when you remove the CaCO3, you will get propanone, Abi. So propanone is one of the products. Is that okay? Then for the second one, we have done it before. HC double bond O, O, Ca, O, C, double bond O, H. Are you there? When you do for this, you get methanol. That's another product. So now you will mix this and this, meaning that just take a side of this one and a side of this one, join them together. So you're going to have CH3, CO, O, Ca, then join it to one of the either way, O, C, O, H. Is that okay? So now what do? You can remove, if you remove this CaCO3, you will get ethanol, Abi. If you remove this, you will still, if you remove this, you will still get ethanol. Shall you get? So let's remove it. CaCO3. So this will give me CH3, C double bond O, then H. That's ethanol. So if you mix them together, you are going to get propanol, methanol, and ethanol. So those are your likely products when you mix them together. Kogi, what happened? Are you lost? You did not understand that. No, you didn't. But you said no, sir. No means you did not understand. No, I did not. Yes, I do. Or I did then. I think we are true. So go and drink water on that. Is there any question based on all the things we have done so far? Is there any question from any side? Who is that? Koshona. So I think we have tried. We should have started around 10, but I was busy. I got here around 10, but I had to quickly sort something before coming here. So sorry about that. So in the course of the week, while you are reading, if you have an aspect that is giving you problem, please send it to me. I will compile them. If I have chance by next Saturday, we'll see again. I have exam on Tuesday, next week Tuesday, biochemistry. But we'll do our best. I'm not trying to be best graduating student, and I cannot keep myself. I will read. I should not fail. So I'll try my best. So by next week Saturday, we'll see. Is that taken? Is the online still active? So if you are reading and you have any problem, you can send it to me. Any topic you want us to treat physics, chemistry, biology, you can go and read aptitude on your own. So you can drop it in the group or comment section. Try to subscribe, like, and share with friends and enemies. All of you that have not subscribed to the YouTube channel, go and subscribe. Click on the subscribe buttons, on the subscription buttons. Go to TikTok to go and follow Dr. Sodium. On YouTube to go and follow Dr. Sodium. There's another channel for Dr. Sodium. That's where we will use for medical related issues. But this one is for our jam classes and all. WhatsApp number.